Hello, my friends. Welcome to my channel, Talk the World. Today we are going to talk about a big thing, which is supply chain. Now the whole world is actually composed of countless supply chains, and this huge supply chain system, at this moment, at this very second, at least 150 million people and 30 million factories are running on this supply chain system. It's like a cycle that repeats itself over and over again. I bet you won't believe it. Supply chain management is one of the best jobs out there now. You can see that all companies that have ever been able to reach the top have been masters of supply chain management. For example, Tim Cook was the CEO of Apple before he became the head of supply chain. And Xiaomi, well, that goes without saying. The killer move is supply chain management. I believe that many of you may subconsciously think that supply chain is not complicated. You just produce, transport, and sell. That's all there is to it. Well, today let's talk about what makes supply chain so complex, how it has evolved step by step, and how it will evolve in the AI era. The founder of modern supply chain is Ford. In the late 19th century, when cars were being made, he divided workers into groups, and each group had to follow the entire production process. This required high standards for workers. They had to be all-rounders, and it also led to a lot of labor surplus. So in 1913, Ford made a decision that would go down in history, to build a production line for his T-type car. He divided the assembly of the entire car into 84 independent steps, so that each worker only needed to take care of one step. The benefits of the production line are clear to everyone. It directly increased Ford's annual output from 10,000 to 1 million, a 10-fold increase. That's why they call him the king of automobiles. But I'd say he should be called the king of production lines or supply chain. Well, once the production volume increases, new problems arise. Although the efficiency of production has greatly improved, but the upstream raw material supply cannot keep up. For example, steel and tires often run out, which means that such a precise production line has to wait for the arrival of upstream materials. Ford's solution was simple and straightforward. You can't keep up with the upstream supply? Then I'll make them myself. After all, I have money and land. He integrated all the component factories, such as glass factories, tire factories, rubber factories, cylinder machine factories, etc., into one large integrated factory in Michigan to ensure that core components could be used immediately. You see, back then, although the term supply chain management hadn't yet appeared, Ford had already taken the first step. That is, the production line plus vertical integration. Later, Ford's iconic production model attracted bosses from all over the world to learn and seek advice. His factories almost became tourist attractions. And among them, on a day in 1929, a 35-year-old Japanese man, after visiting the Detroit factory, was greatly inspired and decided to build a car himself. This person is Toyoda Kiichiro. Toyota originally wanted to copycat, just like Ford, but he found a big problem. Ford's integrated factory was 3.6 square kilometers, with glass inventory, tire inventory, and vehicle inventory. Japan, which lacked natural resources, wouldn't even dare to break a piece of steel plate in half, let alone waste inventory. So for Toyota, the production line I can copy, but this vertical integration, it doesn't suit me. Toyota slightly modified it and came up with a JIT, just-in-time mode. The core pursuit of this mode is zero inventory. You use it when I produce it, and try to reduce inventory as much as possible to improve supply chain efficiency. But this isn't easy. You want to order small and urgent orders from so many suppliers. Toyota wants to adjust production according to demand. Today I need 50 units of this. Tomorrow I need 20 units of that. This kind of small and urgent order, no one is willing to accept it. Toyota thought of a compromise method. He divided the component suppliers into two categories. For those core component suppliers, I'll invest in you, and you'll set up a new production line for me. As a major shareholder, I'll always prioritize you. When you're free, you can take other orders. For those non-core component suppliers, he adopted a strategy of being a sea king. Find several backups. A is busy. I'll find B. B is busy. I'll find C. Someone must be available, and they can compete with each other. Lowering prices. Toyota's approach is still quite common today. Apple also adopts this strategy, which we will discuss later. In any case, Toyota's Git model may not be the optimal solution, but from the perspective of supply chain management, it has indeed evolved. Ford used to focus on speed. I would just work hard and produce as fast as possible. But with Toyota, it considers the demand end of the supply chain, so I can't just keep my head down and produce. I have to raise my head and see what the market needs. Now, one of the most important indicators for analyzing a company's supply chain management is inventory turnover, or inventory cycle. It measures how long it takes for an item to sell after production. This actually considers demand. When talking about inventory, I clearly remember our first required course in college, Principles of Economics. The first class, the teacher asked us a question right away. Why do restaurants offer discounted dishes? Everyone might think it's because they're cheap to promote sales and attract customers. These are all true, but there's another very deep thought behind it, which is inventory management. A restaurant's menu often includes dozens or even hundreds of dishes. As a restaurant, you need to prepare many fresh ingredients. That's inventory. However, if I launch a discounted dish today, say half-price Peking duck, I already know that it will definitely sell well. So I can prepare a lot of ducks and peanuts and less of other ingredients. So you see, the restaurant uses this discounted dish tactic to guide demand to Peking duck, helping them better manage their inventory. So the efficiency of the entire restaurant's supply chain improves. So you see, the essence of supply chain management is to connect the production end with the demand end. No matter how complex the technology, methods, or models become later, at its core, it solves the problem of flow between production and demand. Later, with technological development, the supply chain began to upgrade. The first major advancement was automation. Machines work faster than humans. This is easy to understand, but do you know the difficulty? If something goes wrong, what should it do? In early days, there wasn't a good error correction mechanism. The beverage bottling line had a bunch of conveyor belts, and every few seconds a bottle would come over. Then above it, a nozzle would start spraying the drink. But what if the bottle came at the wrong time? There's no bottle here, but the nozzle doesn't know, it just keeps spraying. Could make a mess everywhere, and it might affect the next bottle. This mistake sounds silly, but the problem is you don't know what kind of weird mistakes the supply chain might encounter. So back then, beverage manufacturers had to hire people to watch the lines. If there was a problem, they'd pull the plug. Finally, in the 1970s, industrial companies pioneered the production line control system called Programmable Logic Controller, or PLC. This term can be remembered briefly. It's a common abbreviation in industrial supply chains. Now, almost all automated assembly lines, including elevators, office buildings, and amusement parks, are filled with various PLCs. They act like the brain of the factory with CPUs. You can write programs ahead of time, such as identifying empty bottles, coming in and spraying, controlling the speed and quantity. So the assembly line can fully achieve automation. Previously, these machines might just work blindly, but now you can use if statements to determine what happens when certain conditions are met. In the 1980s, companies like IBM, Walmart, Toyota, Procter & Gamble, etc., all saw significant improvements in automation efficiency due to the spread of PLCs. It can be said to be a reformation of the supply chain after Ford's assembly line. Now, the beverage bottling line can reach speeds of 10 to 20 bottles per second. And among PLC manufacturers, Siemens Simatic is the leader. Today, about 1/3 of factories worldwide use Siemens controllers. Industrial automation has evolved to a very sophisticated level. There are giant mechanical arms in factories, and there are ATVs that help with transportation and intralogistics. So, let's say that you are now walking into a factory, which is highly digitalized and automated. You won't see many people in the production line. It's all those machines and equipment running orderly, and people are getting fewer and fewer, but the factory is busier than ever before. For example, Siemens has a digital factory for industrial products in Chengdu. which was rated as one of the first lighthouse factories by the World Economic Forum. You can see its unmanned warehouse with a height of 18 meters and several floors high, which uses mechanical arms instead of manual forklifts to put raw material boxes accurately within centimeters into storage slots. Xiaomi and Gree are also now working on so-called black light factories, where no lights are needed, and various robots are busy inside. Thanks to automation, the possibilities of supply chains have been greatly opened up. I'll give you an example that is most typical. Apple was once in crisis during the years when Steve Jobs left. Its product lines were particularly bloated. The good ones couldn't keep up with demand, and the bad ones had inventory buildup. So, Apple lost more than $1 billion in losses before Steve Jobs returned. After his return, he immediately realized that Apple's core problem at that time was supply chain management. He then recruited a key figure in supply chain management, Tim Cook. Cook said that inventory is the root of evil. The first thing he did after returning was to work with Steve Jobs to implement the Toyota just-in-time model, cutting down inventory, reducing product lines, and reducing SKU to adopt a lean asset model. All components that could be outsourced were outsourced to suppliers. He also learned from Toyota's negotiation model to bind suppliers. However, Apple encountered new problems again. Electronics products have shorter update cycles than cars. Apple has so many suppliers. The information transmission chain becomes longer and less accurate. For example, a worker on the production line finds a shortage of raw materials. He tells the supervisor, "Sorry, there's a shortage of raw materials. I may be late by 2 days." The supervisor reports this to his boss, who thinks it's better to add some buffer, saying, "I may be late by 5 days." The boss notifies the assembly plant downstream, adding some buffer, saying, "I may be late by a week." The assembly plant tells Apple, "I may be late by 10 days. You can see that what should only take 2 days to delay has become a big mess due to the long information chain in the supply chain. This kind of orderly information causes various problems in the supply chain, which is very common. It has a professional term called the bullwhip effect. Don't think it's something sexual. It's like holding a whip in your hand. When you shake your wrist, the end of the whip may generate huge fluctuations. This describes how inaccurate information can be. Now, let me tell you about the solution to the bullwhip effect. Apple invested in a software system to manage the entire supply chain information, including sales forecasts, channel inventories, and shipping information to suppliers, etc. All of this can be transparent. This system is called Enterprise Resource Planning, or ERP for short. It's also an abbreviation. You can remember it. Don't worry, I didn't make a mistake. With this ERP, customers can open their computers every morning and get real-time information about the daily production capacity and yield rate of all suppliers around the world. Just click on the mouse to adjust inventory, fund collection, and other operations. With the help of this system, Apple reduced its inventory cycle from over 30 days to only 2 days by 1999. Sometimes it can even be as fast as 15 hours. No wonder Tim Cook became CEO of Apple later. That's because of the informationization. You might feel that it's a very abstract word. It doesn't seem to mean much. But I want to tell you that the promotion is actually very slow, especially for some large enterprises. Some companies even encountered setbacks in the process of promotion. Let me give you a famous example. Nike sales skyrocketed in the 1990s, leaving behind competitors Adidas and Reebok. In 1999, Nike decided to invest heavily in upgrading its supply chain management system. It hired IR, a supply chain management company, to build an ERP system at a cost of $400 million. It was similar to Apple's system, claiming to be able to accurately predict orders and reduce manufacturing cycles from 9 months to 6 months. Anyway, it sounded great, but they didn't expect that the complexity of the ERP system was far beyond their expectations. As you know, Nike has so many goods, the demand forecast would be completely wrong. For example, at that time, Nike had a shoe called Air Garnet 3. The system seriously overestimated the sales of this shoe, causing Nike to stockpile a large number of them. In the end, They were forced to reduce the price from $140 to $90 for clearance. Meanwhile, Nike's other shoe was called Air Jordan, which everyone is familiar with. The system predicted it very low, resulting in insufficient production capacity. It's like I have a restaurant where a big plate of Kung Pao chicken is ready, but everyone goes to order Mapo tofu. What should I do? I can only resort to special dishes. In short, what started as an internal update within the company ended up causing serious internal paralysis at Nike. It is estimated that the losses amounted to at least $100 million, and the stock price plummeted by 20%. Finally, it took Nike 7 whole years, to fix and complete the new ERP system. I use the example of Nike to tell you that such system updates are not a one-time thing. However, information management systems like ERP play a crucial role in supply chains. They greatly weaken the bullwhip effect of complex supply chains. It emphasizes not just my own speed of production, but also the speed of information transmission. How can communication between production and demand be faster and smoother? Recently, however, many people may feel that the ERP system is outdated. That's another story. Let me talk about feedback and flow of information. I'll tell you that there's an industry that has taken the feedback speed of the supply chain to the extreme fast fashion. You see, products like Apple Electronics are updated every year, but fast fashion brands like Zara and H&M are different. Why did they rise? Because they continuously launch new products at a rapid pace. They might even release hundreds of new products in a few days. So for their supply chains, it's critical to know which products are popular and then quickly ramp up production to meet demand. For example, Zara used RFID technology when IoT was booming in the 2010s. They tagged each product with a tag so that real-time tracking could be done from production to inventory to circulation to consumer purchases and returns. Even manual statistics weren't needed. All the information would automatically feed back to the system. They knew which products were popular, and then they ramped up production and replenishment accordingly. Now, it seems even more exaggerated. They might release thousands of new products a day. They've built on Zara's model and come up with a small batch, fast turnaround approach. They first identify trends and consumer preferences through content on social media, find designers who create lots of new designs, and then produce only a few hundred pieces per new design. At the same time, they put these new designs on e-commerce platforms to quickly test user preferences and then ramp up production based on user feedback. This is fast reverse engineering. The extreme feedback speed allows Zara to release thousands of new products a day, helping it sweep the world. Of course, we're just looking at the efficiency of the supply chain from the perspective of fast fashion. Its extreme speed will inevitably bring environmental issues and quality control problems. You see, Zara is now working hard to address these issues ahead of its IPO. We can also discuss Zara separately if we have the chance. Well, we've talked about how production and demand interact at various levels. Productivity continues to break records, and feedback speeds become faster and more precise. It feels pretty impressive, right? But I want to tell you that as market environments become increasingly complex and uncertain, the supply chain is advancing to a level that's almost sci-fi. I'll give you an example of a hot industry right now, lithium batteries. The explosion of the new energy industry is visible to the naked eye. Since 2019, more than $300 billion has been invested in the battery industry. Driven by electric transportation and energy storage, the annual production of batteries is expected to reach billions of units by 2030. Globally, there will be 200 giant factories built for batteries. For lithium batteries, it's not just about quantity increases. The speed of technological innovation and iteration is particularly fast. Take Ningde Times Xinxing series as an example. It may iterate 4 versions in a year. The requirement for product iteration efficiency is at an extreme level. So now some battery manufacturers have adopted simulation and visualization methods to simulate and visualize the entire R&D and manufacturing process. This is somewhat similar to industrial metaverse. The digital world is essentially a mirror image of the real world. It's called digital twin. You hear the word digital twin and think it sounds cool, but what does it actually do? The supply chain is most concerned about actual results. It doesn't care whether it's cool or not. We just talked about batteries, which is all about speed. They need to be fast in research and development, and they need to be fast in production. And digital twins can help them achieve this kind of efficiency. By visualizing their simulations and models, they can simulate almost every possible scenario ahead of time, find the most efficient and safest solution. For example, in R&D, you would have to prepare materials first, assemble them, test them, could take months. Battery manufacturers use digital twins to simulate the entire process of R&D and production in a 1:1 virtual world. Because physical properties of materials and some chemical properties can be simulated, you can see how different material ratios affect electrolyte flow, how each step optimizes the process. Engineers can evaluate the impact of various formulas on battery performance, aging safety, etc., then optimize and iterate. This can greatly accelerate the R&D and testing cycle. It's not just for lithium-ion batteries. Products like cars and ships that are very complex and require high performance are now using digital twins as well. For example, when you design a new car, you can do wind resistance tests and crash tests in the virtual world first. Siemens and NVIDIA recently collaborated to create a shipbuilding digital twin, helping a shipbuilding company simulate and experiment with a ship with over 7 million discrete parts. The accuracy and efficiency are unimaginable even 2 years ago. In production, it's similar. You can simulate the entire factory or supply chain process in the virtual world. I listened to a talk by Tesla recently. They explained how Siemens helped these lithium-ion companies build ego-factories. They would first simulate things like machine placement, assembly line design, employee positions, etc. in the virtual world, then build them brick by brick. Not only will the construction efficiency be higher, but you can also find many risks during the testing phase and avoid them. Otherwise, if you build an entire gigafactory and then discover bugs, wouldn't that be embarrassing? Besides digital twins, I'll mention another emerging direction, which is blockchain technology. Don't think of blockchain as Bitcoin. Blockchain technology can be applied well in supply chains, can store information completely and cannot be tampered with. It's very suitable for storing supply chain information. For example, if you put all the ingredients information on the back of food packaging on the blockchain, it's easy to trace the source of any food safety issues. Nestle, Unilever, Carrefour, etc. are now trying to track food supply chains with blockchain technology. Digital twins, blockchain, AI, etc. These digital technologies actually form a virtual digital world, which is called the industrial metaverse. Did you notice that words like robots, blockchain, and metaverse, which are so hot right now, may seem like hype at the consumer end, but at the business end, from production to supply chains, you can really see some practical applications. So from this perspective, supply chains can be said to be pioneers in human technological development. How about I start with this sentence? You've seen how supply chains have evolved over the past 100 years, from speeding up production with assembly lines, to considering inventory and demand, from automation to digitization and intelligence, all aiming for increasingly efficient operations. Workers' efficiency, the efficiency of factories and warehouses, information feedback efficiency, etc. Recently, they're also focusing more on safety and sustainability. That's all for today's content. See you next time for more exciting content.